The most common use case for anonymous types is most definitely when using LINQ. We briefly looked at using LINQ in the previous module that covered extension methods. You can use LINQ in two different ways. Either you use what we looked at earlier, which is known as the method syntax. You can alternatively use a query syntax that would allow you to express complex queries in a more simple manner. Whichever of the two you prefer, they can be used together with the anonymous type. In the warehouse management system, let's say that we construct a list of orders. Then, each order in its turn has a list of items. We are going to introduce an overload for process on the order processor that accepts an IEnumerable of order. In this method, I'd like for you to create a query that produces an order summary. To do this with the LINQ method syntax, we call the extension method from system.linq called select. This is a simple way of iterating each item and then retrieving that. The call to select accepts a func of order and tResult. This is a generic delegate that accepts the order as the first parameter, and then you can return anything you'd like. This means we could get a complex type passed into this anonymous function and construct a new, simpler representation. This is a great place to introduce an anonymous type. For each order in the list of orders, we are going to select a new representation and create that using an anonymous type. The summary will contain a property that we call order. This is pointing to the order number. It will also contain the amount of items. To count all the items in the list, there's an extension method called count. And finally, the total value of the order based on summarizing all the prices on the line items. And to get the total value of this order, you can use a method called sum. This method accepts a func of item and returns a decimal. Therefore, you can use this to get a summary of all the prices. If we go ahead and call this method in the program and then run this application with the debugger attached, as we step into this method, we can see the result of our LINQ query. We can see that the result of calling select produced an IEnumerable containing an anonymous type. Each item in this array contains an instance of the anonymous type. As long as we use this within the same method, we'd be able to reference the properties created on this anonymous type. The compiler will have generated a class for you that corresponds with the anonymous type used in the select method. We can verify this by looking at the decompiled source code and see that it did in fact produce an anonymous type with the properties order, items, and total. To take this one step further, since this produced an IEnumerable, you could use LINQ on the result from the select method as well. Let's order the summaries by the total value of the order. To do this, we can use a method called orderBy on the summaries instance. This will behave very much like the other LINQ methods that we've looked at. In this case, it's going to be an anonymous type that was produced by the select method. If you hover over the summary variable used in this lambda, you can see that this is the anonymous type. The compiler inferred this for you. Since this is a generic method and the language is strongly typed, you can access all the variables on this anonymous type, just like if the class was created by yourself. We will now have a list of order summaries that are in order of the total price. You can iterate through this enumerable, use the properties from the anonymous type, and print a summary to the console. This works really great. As long as we use the anonymous type within the same method, we won't have any problems. When you work in UI applications, where some of the components in the UI are data-bound, that means you want to attach what that element in the interface represents by binding it to an instance. Using an anonymous type can be very powerful. Let's jump over to the Windows project and look at an example of how to do this. I'm going to extend the UI with a data grid. Again, this course isn't about WPF, but it's going to illustrate a good use case for anonymous types. With this data grid available in the application, I'd like to populate this with the summary of my orders. I'm going to head over to the main window .saml.cs and introduce a new method that works with the order summaries. I'll create the same list of orders and items that we had in the program. Imagine that this data was loaded from a database. I don't really want to make it too complex, so let's just create a temporary list in this class. Now, introduce the same functionality that we looked at earlier. This will select an anonymous type based on each element in an array of orders. After this new array of anonymous types have been produced, we can order this using LINQ. This should look very much like what we had earlier in the console application. I'll use some WPF-specific code to bind this collection as a source on the data grid. What the data grid will do now is produce a nice representation using the property names on that anonymous type. And then it will fill this grid with all the data from our array. If I call this method when the window is created and run the application, you can see that the data grid is filled with the order summaries. It automatically created the columns and headers based on the anonymous type. You can add an additional property to the anonymous type to, for example, see if the order is ready for shipment. Then, if we rerun the application, this will now have updated the data grid automatically based on the anonymous type. This is where anonymous types are truly powerful. So far, we've seen how to construct an anonymous type. We've talked about it being read-only, and the fact that we shouldn't use it outside of the current method. There is a way to create a new instance of an anonymous type based on the previous instance with some modified values. Let's look at this next.